All right, we are covering Chapter 5, Section 6. So far, we have covered side angle side, side side side, and HL. We're covering the last two of triangles congruent, okay, how to prove that triangles are congruent, with the last two, which is angle side angle and angle side. So let's go ahead and cover angle side angle. So angle side angle is when you have two angles and the included side. Okay, two angles and the included side of one triangle are congruent to two angles and the included side of the second triangle, then they are congruent. Okay, so this is when you have angle, side, angle, where your side is the included side. If I were to write a congruency statement, looking at this one, understand where I'm getting this information from. I have my first angle, I then have my side, and then I have my second angle, which is on the other side of my side, okay? So if I were to write a congruency statement, my congruency statement would be triangle, I'm going to put BCA, is congruent to triangle EFD. Okay, so yes, it could be written a different way, but again, your second one has to follow the first one. Your first one could be written however it wants, but the second one has to follow. So please make sure that they are written correctly. All right, this one's angle side. So with this one, you have two angles and the non-included side. So when you have two triangles that are congruent using two angles and the non-included side, then they are congruent. So same thing as before, if I have one side, angle, I have an angle, and then my non-included side. So for this one, if I were to again write a congruency statement, I could write it as triangle HJG is congruent to triangle LMK. And this is again when you have two angles and the non-included side, meaning it's not in between my two angles. It's on the outside of my two angles. And yes, it could be drawn on this side and it'll still be considered angle side. So it doesn't matter which side it's on as long as it's not in the middle of your two angles. All right, this is a summary of all of them. So all that we covered side, side, side yesterday. This is when you have all three sides that are congruent. We covered side, angle, side last week. This is when you have two sides with an included angle. So it's in between my two sides. HL is only for right triangles. Only for right triangles, that's when you have one hypotenuse and one leg. Obviously, there's only one hypotenuse, but it has to be a hypotenuse and a leg is congruent. And then we're covering these last two today, angle, side, angle, and angle, side. Keep in mind, the only triangles that can be HL are your right triangles. However, your right triangles can still be any one of these. Okay, HL is only for right triangles, but again, I could have a right triangle that is considered side, angle, side. So it's not always going to be HL for right angles. So make sure you're paying attention to that because it's not always going to be HL. Or it can be HL, but your right triangles, the only thing that can be HL is your right triangles. So just please make sure you remember that. All right, looking at the next one. All right, this is a proof. We're going to go ahead and start covering proofs for the remaining of these. So please pay attention. If you have a question, ask, because I want you guys to understand these. So it's giving us our given. So I'm just going to go ahead and write down my given. So the first one is, please make sure you're numbering these. Angle X is congruent to angle V. Angle YZW is congruent to angle YWZ, and XY is congruent to VY. and that's given. So if you're looking at the diagram, none of the information is drawn on the diagram, so I'm going to go ahead and draw them. So I have x is congruent to v. I then have yzw is congruent to ywz. And then I have yx is congruent to vy. So looking at it, can I use HL here? No. Okay, it's not a right triangle. They're asking me to prove that this triangle is congruent to this triangle. So HL is out of the question. I also cannot use side, side, side to prove that they're congruent. I'm going to have to use something else. Understand that when they're giving you a diagram like this and you have a straight line, I'm going to go ahead and try and find this missing angle. How can I do that? Because of linear pair postulate. So my next step, step 2, is going to be linear pair. And I'm just going to shorten it to LPP, linear pair postulate. And what that states is angle XZY. I'm trying to show or prove that this angle right here is congruent to this one. So they're giving me what I have, XZY, that's what I'm trying to prove, plus angle YZW equals 180, that's linear pair postulate, and I'm going to do it for the other side, angle VWY plus angle YWZ equals 180. Now that I set them both to equal to 180, I can go ahead and set them both equal to each other. So step 3, I'm going to combine them. I'm going to substitute 180 for 180. I'm going to have angle XZY plus angle YZW equals angle VWY plus angle YWZ. And for 3, all I did was substitution. Again, what am I trying to get? I am trying to prove that this angle is congruent to this angle. So I need to figure out a way. To get rid of this one right here. And if I'm looking at what was given, I can see that these were congruent. So I'm going to go ahead and substitute something to get rid of it. So 4, I'm going to keep this here, angle XZY. I'm going to go ahead and substitute plus angle YWZ equals angle VWY plus, I'm going to keep this one the same, but this is what I'm going to get rid of. So for this step, all I still did was substitution. And now I'm going to go ahead and I'm going to use the subtraction property. Again, I'm trying to get the congruent angles by itself. So I need to go ahead and get rid of this. So 5, I'm going to have angle XZY is congruent to angle VWY. And I subtracted. Okay, so right now for step 5, I just proved these angles in blue to be congruent. Okay, so these angles right here, I found that to be congruent for this step. So now if I'm looking at my diagram, how can I prove that these triangles are congruent? What can I use to prove that my triangles are congruent? Which one of the ones that we learned? What kind of triangles are these? It's not HL. It's not side, side, side. So it has to be something else. Yes. It has to be angle, angle, side. Now I can go ahead and write my last one, which is step 6. I can go ahead and write triangle X, Y, Z is congruent to triangle VYW by angle, angle, side. Okay, do we have questions? I know it was a lot. Do we understand how I did from 2 to 5? Why I did 2 to 5? Now is the time to ask questions, guys. Or are we good? We understood it. This is a little bit on the longer side. So do we understand why I set it up to equal 180? How I try to figure out to get these angle by itself and then cancel these out? And then I got my angles were congruent. I cannot just go into stating something's congruent without showing how you're getting there. Okay, do we have any questions on this one? The last one's going to be similar. So if you have a question and you're not sure on how to ask, hopefully by the last one we'll go over it again. All right, go ahead and go to the next one. All right, example number 2, it says JL bisects angle KLM, and angle K is congruent to angle M. They want me to prove that the triangles are congruent. So we're going to go ahead and state first what's given. JL bisects angle KLM, and angle K is congruent to angle M. That's given. All right, little hints. There's the word bisect. What normally comes after the word bisect? Yes. Midpoint? Not midpoint. Midpoint's a little different than bisect. So bisect is to cut something in half equally, which I'm dealing with angles. But similar to midpoint, after bisect is going to come definition of bisector. Okay, if something's being bisected, I have to tell you what will my outcome be once it's bisected. So 2 is going to be definition of angle bisector, or you could just put bisector, that's fine. Who could tell me how would I write my angles if they're being bisected? There's a specific way on how to write the angles. So JL is cutting this angle in half. How would I write that those angles are now going to be congruent? Which angles would be congruent? Does anybody know? How would I write it? Yeah.
Angle LMJ, and angle LKJ.
Well, that's basically saying angle K and angle M are congruent. So I wouldn't say it that way. So I'm going to kind of highlight it so you can see. JL is bisecting KLM. So now looking at the diagram with the highlighted, which angles would be cut in half? Yeah.
JLM.
Okay, we can say it that way. That's fine. Angle JLM is congruent to what? JLK. Or you could switch it around and put MLJ and KLJ. For that, it doesn't matter, but your L has to be in the middle. So I'm going to go ahead and draw that. We just proved that this angle right here is congruent to this angle. What else can I prove? So I have 2 things right now, an angle and an angle. Looking at my diagram, is there something else that I can prove is congruent? Yeah.
JL and LJ.
Good. I can go ahead and state JL is congruent to LJ. They're sharing that side. So what would my reason for this be? Yeah. Reflexive. Good. This is reflexive. All right, now that I figured out that they're reflexive, do I have enough information to prove that these triangles are congruent? Yes, I do. I proved that the triangles are congruent by what? How? What did I prove? Yeah.
Angle, angle, side.
Angle, angle, side. That's my non-included side, and I have two angles. So yes, for 4, this one was done in only 4 steps. I'm going to say triangle JKL is congruent to triangle JML by angle, angle, side. All right, questions on example 2. Questions, comments, concerns. This one was definitely a little easier. Okay, go ahead and go to the next examples, please. All right, these are asking, identify the postulate or theorem that proves the triangles to be congruent. So looking at these, we need to figure out what angles are they talking about. Okay, so look at where they're pointing. Can anybody determine, looking at number 1, what could I use? What theorem could I use to prove that these are congruent? Yeah.
Angle, side, angle.
Good, angle, side, angle. So here are the angles. They're stating that this angle is congruent to this angle. And these angles right here are congruent to each other. So for this one, I'm going to have angle, side, angle. All right, looking at number 2. There are 2 here. Who could give me 1? Yes.
Angle, angle, side. Never mind.
No? Okay. All right, who wants to try this one? There are 2. Who could give me 1? Katya? HL works. Yeah, I could for sure use HL. Okay, just showing you why I could use HL. This is my hypotenuse right here. This is also my hypotenuse. They're congruent. And then I have 1 leg. So keep in mind this 90 degrees is for this corner right here. Okay, so I have HL, or what's the other one that I could use? Yes.
I was going to say side, angle, side.
Not side angle side because there's no included angle in between my side. So I can't use that one, yeah.
Side,
Side angle, there's no side angle. That's not one. So if you think of it as, if you flip it around and put ASS, there's no ASS in geometry, okay? So there's no ASS in geometry. So you can't have ASS, we should know what that word spells, or SSA, okay? Regardless of how it is, you can't have that. So that cannot be one. Yes?
No, I don't know how I said it already.
Okay, what is
Side,
it?
angle, side.
It's not, remember, there's no angle that's included. So these are my sides. Remember, in order for it to be side angle side, it has to be your included angle. They're not giving me that. Gabriel? Side, side, side. Look, this side is being shared. So I have side, side, side. So this one could also be side, side, side. Yes.
Wouldn't 90 be an angle?
Yes, it would be, but remember, I can't have angle side, side. There's, if you look back at the summary, angle side, side is not there. So you can't have any ASS in math. We got it? We got it? I just can't say it because it's recording. But we cannot have any ASS in math. So if you want to put ASS or SSA, you don't put that, okay? Even if that's an option, don't select it. Okay, you cannot have that one. You could have other ones, but you cannot have that one. All right, so looking at 3. Let's go ahead and do this one. What do I have? Yeah.
Side, angle, side.
Side angle side. So I'm getting that angle because it's vertical angles. So this can be side angle side, or there's another one. What is it? Yeah. Good. Side, side, side. Okay, so you can have multiple for some of them. So definitely check. Yeah, go ahead. You're good. All right, questions on these 3. All right, one more proof and then we're done. All right, so looking at this one, this is similar to the first one. So we're gonna have more steps than 4. So looking at this one, go ahead and we should kind of know what the first one is gonna be. It's gonna be what's given. So I'm just gonna go ahead and write all of it. Angle FAB, FAB, is congruent to angle GED. Angle ABC is congruent to angle EDC. And segment AC is congruent to EC. So this is all given. Just be aware nothing is drawn on my diagram. So like I said in previous lessons, best thing to do when they're giving you a diagram is draw the information so you could try and find out what's missing. So right now, FAB is congruent to GED. ABC is congruent to EDC. And then AC is congruent to CE or EC. So this is what I have right now. Let's go ahead and figure out what else do we have to find. So it can't be HL. It's not going to be side, side, side. It can't be angle, side, angle. Why can I already determine that? Because this is not on one of the included sides. Okay, so right now I'm down to 2. It's either going to be angle, side, angle, or angle. No, it can't be angle, side, angle. It's going to have to be angle, angle, side. So now I need to figure out which angle can I find. So if I'm looking at it, I can't find any of these angles because there's no information to go off of. So I'm going to have to use this angle right here. And again, I have a straight line. I have a part of an angle that they're already giving me, so I should be able to cancel that out. And then I could hopefully prove that these two angles are congruent. So like we did before, I'm going to use linear pair postulate, LPP. And I'm going to state angle FAB plus angle BAC equals 180. And I can state it for the other side. Angle GED plus angle DEC equals 180. So do we all see where I'm getting that from? Do we all understand why I'm choosing those angles? Okay, now because they're both equal to 180, I can go ahead and set both of those expressions equal to each other. So for 3, I'm going to go ahead and write it as angle FAB is angle FAB plus angle BAC equals or is congruent to angle GED plus angle DEC. And again, all I did for 3 is substitute. All right, now what do you think I should be able to do? Remember, what I want to do is I want to prove that this angle is congruent to this angle. So I have to try and get those angles by itself. I have to try and get this angle by itself. And I want to try and get this angle by itself. So what should I do next? What can we do? What do we know? Good, I can go ahead and substitute. I am going to go ahead and look at these. And if I look here up top, they were congruent to each other. So I'm going to go ahead and substitute it because I'm trying to cancel it out. So doesn't matter which one you do. I'm just going to go ahead with the first one and I'm going to change this to GED. And then I'm just going to go ahead and bring everything else down. Angle BAC equals angle G, not an E, GED plus angle DEC. So right there, I still substituted. So if you're looking at it, you should be able to notice that I have something is the same. I'm going to go ahead and get rid of the GED on both sides. So I can go ahead and cancel these out. So I'm going to have left angle BA. Let me get a darker blue. Or I'll use a lighter blue. Angle BAC is congruent to angle DEC. And I got here by subtraction. Okay, so if you're looking at it, I just proved that these two angles right here in blue are congruent by using step 2, 3, and 4. Now, do I have enough information to prove that these triangles are congruent? Yes, I do. Of course I do. So how are these triangles congruent? Triangle ABC is congruent to triangle EDC by what? Yes. I flip it around. Angle, side. Angle, side. Okay. Do we have questions on this one? Do we all understand where I'm getting all this information from and why I can get this information? That's something that you guys have to be able to look at and figure out when you're taking your test. Okay, so your test is on Tuesday. The chapter review is already on Canvas. Okay, it's not covering chapter 4. Your test is only on chapter 6. Yes. How I got from which step? 3 to 4. I substituted. So I know I can get rid of. So I'm trying to find that these two angles are congruent. That's what I'm trying to keep. But up top, I kind of highlighted in yellow. FAB is congruent to GED, so that's what I substituted. I changed my FAB to GED, and then that's how I canceled them out. Okay, so always look back to what's given to help you in the ones after. Okay, questions, comments, concerns. All right, homework. Please show your work for your proofs. That's it.